The Queen Space Engineering Team is a design team at Queen's University where we build a Mars rover each year. At QSET, we believe that space exploration is the next great feat for mankind. QSET is made up of 3 technical subteams, mechanical, electrical, and science, and 2 logistical subteams, PR and sponsorship. This year, each subteam has been working hard in order to prepare for our 3rd appearance at URC. QSET will be a strong competitor this year at URC as we spent the last 3 years learning from our mistakes and improving our rover year over year.
The mechanical team has been extremely busy designing and fabricating the various mechanical and electromechanical systems for the 2016 University Rover Challenge. Similar to our previous chassis, this year's design is built with aluminum extrusion. This allows for easy design modification, giving us the ability to iterate on designs more extensively and efficiently. This year we have taken the design and made the suspension arms longer to adjust to the increased chassis dimension and also to increase the ride height, making it easier to pass over obstacles. In addition to this, we have been able to cut out 50% of the weight from the suspension arms. This year, the arm has been redesigned to give a greater range of motion and the geometry of the arm has been optimized. With the inclusion of an additional pivot joint, the robotic arm is now able to place items on top of the rover, as well as reach items far on the ground in front of the rover. The geometry, combined with our newly designed high torque end effector, will allow us to excel at the astronaut assistance task.
At the heart of our rover is a Raspberry Pi 2, which manages the network connection as well as the control of all external sensor, servo, and motor ports. Control of these systems is performed by the Pi through a slave Arduino Mega. All of these external connections are facilitated by brand new printed PCBs. These provide a standardized way for us to interface with a plethora of external sensors and control devices at various voltages and currents, while having the added benefit of reducing clutter of the rover's internal connections. The Pi's camera port is attached through a multiplexer in order to provide 4 external camera connections. The external cameras are interfaced directly with the GPU of the Pi, providing near real-time video at HD quality with little to no processing overhead on the Pi. The software used to control the rover has been completely redone this year and is instead served as an HTML5 web page. This allows for on-the-fly changes to the rover while also allowing multi-user access. For example, it will be possible for the science team to take sensor readings while the driver simultaneously pilots the rover. This year's communication system features 2 Ubiquiti Networks high-gain omnidirectional antennas. The system operates at 2.4 GHz with suitable performance at 0.8 kilometers with no line of sight.
This year, QSET decided to utilize Protocase's generous sponsorship of URC to develop a fully encapsulated and modular control box for the rover. The electrical box was a joint effort between both electrical and mechanical teams with mounting points for all electrical components, easy access to the various ports of each PCB, and built-in connectors for motor and actuator interfacing. This new design gives the team the ability to hot swap components out due to failure or damage between tasks while improving wire management and reducing debugging time.
The science team has come a far way since our inaugural year in the fall of 2014. We began the year completing research in the areas of current Mars missions, the geology of Utah, as well as Martian geology, chemistry, and the implications of the newly discovered water. This led us to design and decide upon our experiments that we will conduct in competition. This year, we have a multitude of sensors and experiments to test for signs of life, to characterize the environment, and to classify the local geology. We have a soil probe that will be on board the rover to test for soil moisture, electrical conductivity, subsurface temperature, dielectric permittivity, and the volumetric water content. In addition to the soil measurements, we also have a suite of air tests such as a weather station, an air pressure, temperature, and humidity meter. The signs of life we will be testing for include lipids, proteins, and sugars, the 3 organic macromolecules that make up living things. We are currently testing all of our experiments in preparation for URC. Through this, we will confirm our expected values, calibrate the tests, and become more comfortable completing them in a limited time frame.
This year, for our sample storage system, QSET is using a mechanism inspired by the Curiosity rover. This consists of an auger bit coming out of a funnel with an elongated spout. To take a sample, the mechanism is stuck into the ground 5 inches, at which point the spout of the funnel is touching the ground and material is augered into the funnel. To store the sample, the mechanism is pulled out of the ground and tilted back 90 degrees, at which point the dirt will fall out of a hole outside of the funnel and into our airtight storage containers. This year, QSET has raised the bar from wire management, electrical subsystems, to mechanical systems such as drivetrain and manipulators. Our science team has also greatly improved this year, drawing students from across the university, really gaining depth in research and experimental work. As we move into March, all sub-teams are on task and ready for URC 2016, and we look forward to seeing you there.